Okay, we've been exploring variables of moisture, temperature, pressure. Guess what? All of those combine to form wind. So we're going to talk about wind this week. It says wind and weather, but the real focus will be on wind. So what is wind? Wind is just motion of air moving along. And there are certain forces which control the speed and direction of that air to make the wind. One thing with wind is two-dimensional. It has a speed and it has a direction. So that is very different than the other variables we've talked about in the atmosphere so far. So it's a local motion of air. It has a push, there's a force. And Newton's second law of motion says a force is equal to the mass of something. Or in other words, think about density. The more dense an object is, the more mass it likely has times some kind of acceleration. That acceleration can be all kinds of things, including gravity or stability, for example, in the atmosphere. So if you have isobars that are close apart, the pressure gradient is going to be pretty strong. So if I have a big high and it's going to a low pressure over here, perpendicular to that, from the high to the low, is going to be a pressure gradient force. The closer they are together, the more I'm going to run downhill towards fill in that gap. The same as if you were climbing a steep cliff or a mountainside. The steeper it got, the tougher you're going to find your climb because you're going to want to go down very quickly down that steep slope. When it levels off, you don't need to go quite so hard. The same happens with air. Air is going to want to move very quickly down a steep slope, not so fast when the isobars are spread out. There's another force, centripetal force. Centripetal force happens I think about it with a car. If I'm going around a corner, centripetal force is what keeps me from flying out into space or missing my turn. So that is something that it's always center seeking, and it's what holds objects in a circle, such as this person spinning that ball around. There's another force. Because the Earth rotates, we have Coriolis effect. So let's take a look at that a minute here in the US. Say you have an object that's right here at that moment in time. The Earth rotates from the west to the east. So that same object is going to feel a force acting on it to the right, because even though that northernmost point hasn't hardly moved, where it's at has moved as the Earth rotates. So by the fact that the Earth is rotating, there is a force acting on that air parcel that's pushing it to the right. Here you can see it. All the deflections, and stronger the further north you get, and less at the equator. But these are all forces that act on that object with Coriolis effect. Friction is another force. Think about it if you're moving along over a body of water, you can see the wind moving along. That wind hits land. Well, what happened? Well, the body of water was fairly flat. Maybe you had a few waves. But when it hit land, you probably had some hills. You probably had some bushes. That air is going to slow down because of the land friction. So you're going to see that in one of your questions this week. It's going to ask about winds coming off the water, sea breezes, or land breezes. What causes the clouds to form? Remember this, it's friction that's going to slow the wind down as it's coming off of the water into the land. And when that wind slows, convergence is going to develop. Gravity is another force. It pulls objects down. Gravity does not work in the horizontal. It works north. It works from the vertical only, up and down. So now that we have these forces, how the heck do they combine? Well, one area is the hydrostatic equilibrium. Think about it. The pressure really drops pretty quickly. When you go up in the mountains in West Virginia, pressure drops very fast on the vertical. So there is a heck of a pressure gradient in the vertical. What keeps all our atmosphere here then? Instead of just going right out into space. What keeps it here is this hydrostatic equilibrium that is combined with the fact that we have gravity that holds it down. It offsets that vertical pressure gradient so that the air parcel is steady. If the air parcel can still move, it can move up or down. It just can't accelerate with hydrostatic equilibrium. So that is one key component of hydrostatic equilibrium. It holds the air parcel in place. Now, you can have parcels hitting a mountain and they move up, parcels coming down the mountain and move down, but they are not accelerating because of hydrostatic equilibrium. There's another force that combines two, geostrophic wind. Meteorologists like to approximate everything, and this is just taking two forces, Coriolis effect and pressure gradient. So the pressure gradient right here is always down towards low pressure. So when this parcel starts out, it's going down that way. But because it's moving to the right of it will be a Coriolis effect. And eventually you wind up with pressure gradient and the Coriolis effect are equal. And the air parcel is basically just flowing right along between the isobars, or in this case, contours. So what happens then is you wind up with air moving in a straight line. It is balanced between the pressure gradient and the horizontal Coriolis effect. Now, we know that around highs and around lows, the wind blows in a circle. So what is happening there? Well, you've added a third force, centripetal force. Centripetal force is always changing. So that is what's causing it to go in a circle as it goes around the low or around the high. So remember the difference. Gradient force has three forces. It has the pressure gradient force, the centripetal force, and the Coriolis effect. Geostrophic wind only has two. It has the Coriolis effect and horizontal pressure gradient. So when you get down into the boundary layer or the lowest level of the atmosphere, near the Earth's surface, friction plays a role. What does friction do? Friction offsets the speed of the wind. So it's kind of acting to slow it down. So whereas further up in the atmosphere, higher up, the pressure gradient force and the Coriolis effect are balanced. Now they're not because the wind speed has changed. So you wind up going towards low pressure and away from high pressure. So this is a balancing act again in the lower levels of the atmosphere where friction plays a role. And you can see it on any cyclone. Now there's a continuity to the wind. There are horizontal divergence and horizontal convergence. When wind is moving apart, there's divergence. When wind is coming together, there's convergence. And so if wind is coming together above you somewhere, then you have sinking motion downwards. You can wind up divergence at the surface, or air will try to sink downwards. The opposite convergence, think about it at the lake breeze, or coming in off the ocean, or a cold front maybe. You might have very strong winds coming out of the west. And on the other side of it, the warm air is coming out of the southeast. What are they doing? They're converging. So air has got to rise. And especially if you can get divergence aloft, it really helps that rising motion. So that's why you wind up with a continuity of the wind. What is happening at the ground level or aloft influences either or. So with that, let's take a look at just a couple things here. This is a 500 millibar chart today. I got this out of the University of Wyoming. Look at the winds, how they parallel these contours. Not much difference. The stronger the winds, the more parallel they are. The more tighter the wind the gradient is, the stronger the winds are. This is a classic example of a geostrophic wind. So now let's bring it down into surface weather map. We look at the high pressure here. Winds are much lower, and they're coming out of the north, around the high, coming out of the south on the other side. But they're coming away from the high, and they go in towards the low. So you can see here friction playing a role in this. If I went back in this one and brought it down a level, so let's not look at 500. Let's look at 850 millibars. Friction begins to play a little bit of role in that when you get down to that level. So sometimes you wind up with a little bit more across the contours flow around the low here, out of the high here. And finally, just looking at an upper level sounding, Oklahoma City solidly in the cold air, but its cold air is only about 3,000 feet thick, so it's not real thick. And look how the wind shifted. Right at that level, all of a sudden it went to the south. So this is saying that there is divergence maybe below it, maybe convergence above it. And you can see all of these winds are impacted with what's happening on either below or above it to make it work. So this is just some of what you're going to be dealing with this week in winds. I hope you get it. The critical thinking questions have messed up a lot of people. So if you have questions, please don't hesitate to ask.